Good day, students. Once again, we continue from the previous recording. And in the previous recording, I highlighted that we will be doing the second version of the conversion. And I made mention of the fact that the second conversion or the second version of the conversion has its own formula. Let me just change the color. Previously, I've used too much of this color. Let's go to this one. Now we said we have this formula. Now what I want to bring to your attention is the fact that it says conversion of one nominal rate to an equivalent nominal rate. Then you're like, how do you convert nominal to nominal? It further says the conversion, there's an E that I forgot there. The conversion of one nominal rate to an equivalent nominal rate is given below. And here is the formula on how to convert nominal into nominal. Then now let me bring your attention to the note that we spoke about previously in terms of the understanding of this conversion. It says, note, the nominal rate is a rate that is used in calculating the periodic interest on a monthly basis, or compounded monthly, compounded quarterly, compounded half-yearly, or compounded daily. Could be any one of them. Now that means when we are doing the conversion of the nominal to nominal, we can convert quarter into month, or convert month into half yearly. We know that we have monthly compound. Let me just explain this in this format. We have monthly compound, we have half yearly, we have quarterly, just 1/4 quarterly, we have 2 monthly, we have which else daily. It could be any of the compounding period. Interest can be compounded in any of these formats. Now that means when we speak of the conversion, we can convert interest that is compounded half yearly, we convert it into a monthly compound, or we can convert half yearly into quarterly compound, or you can convert half yearly into daily compound, or you can convert half yearly into 2 monthly compound. So you can use any one. You can convert monthly into daily compound. You can convert monthly into quarterly compound. You can convert monthly into yearly, or monthly into 2 monthly, or monthly into daily. Any one of these compounding frequencies can be converted to one another. So now when we're converting nominal into nominal, that is what we mean. Meaning you might be given an interest rate that is compounded quarterly, and you're required to convert it to half yearly or semi-annually. You can be given a rate that is compounded quarterly, which is a nominal rate, and you're required to convert it to a daily compound, or convert it into 2 monthly compound, or convert it into a monthly compound. So now this is what we'll be doing, meaning we will be given a rate that is compounded at whatever frequency, then you convert it based on the instruction that will be given to us. So now let us continue on that note. Now you know that the nominal rate is the one that is compounded monthly, quarterly, half yearly, or 6 monthly, or 4 monthly, or 2 monthly, or daily. Now here the formula that says it converts the nominal rates, which is JM, compounded M times, which is, it could be monthly. Remember, M is the number of times the interest is compounded over a period of a year. M times per year to equivalent nominal rate, which is JN, compounded N times in a year. So that will be the number of years N. So now this is what we are going to be busy converting in this conversion. Then now we have our first example. First example is example 3.10 on the conversion of the nominal into nominal equivalent. Then after now it says in 3.10, find the nominal rate compounded semi-annually. Remember, this is what we are required, and the minute they say find the nominal rate compounded semi-annually, so what you are required in the question is the first side of the formula. That is what you are required, meaning when we substitute here, we need to substitute using the requirement. Then the provided rate, which in this case our provided rate is the one that is over the equal sign. That is equivalent to a nominal rate of 12% per annum compounded quarterly. So now this is the one that is on the right hand side of the equal sign. So now let us go to our formula and we substitute accordingly. Now our formula says 1 plus what is required. We are required to calculate the nominal rate that is compounded quarterly. So it will be I or J. It does not necessarily matter for me which one you use as I and J. If you're confused, don't worry much, to be honest about that. As long as at the end of the day you master the principle and you understand the basic principle very well. Then now it will be J over, then we need to say how often is the requirement compounded. It is compounded semi-annual. So now that is divided by 2. This is the one that is required. To the power of what? To the power of 2 equals, then we have 1 plus 0.12. Please know that when we use the formula, the interest rate must always be in decimals. This is M, how often the interest is compounded, and this is M, how often the interest is compounded. Now what do we do? Remember, first of all, what we're looking for, J, which is, this is the unknown that we're looking for. So we first need to solve this side, but before we do that, we first need to eliminate the power. And how do we eliminate the power? If it's 2, we use the inverse of 2. This has to be times by 1 over 2. And this has to be times by 1 over 2. So whatever you do on the left hand side, you do on the right hand side. First of all, we eliminate the power on the left hand side. That is first step. How to eliminate 2? You just divide by 2 if you want. Or you can say times by 1 over 2. Sometimes when it's a fraction, it's very important to know that we're multiplying by a fraction, which is 1 over 2, and 1 over 2 is the same as divide by 2. So now we do the same thing here. We say divide by 2, which is times by 1 over 2. That is still divide by 2. So now that means we will be left on this side with power 2. Here we'll be left with no power. We always divide by the number of the power that is on your required nominal rate, or on the left hand side of the equation. Then after, what do we do? On this side we have 1 plus J over 2, which is equal. Then now we use our calculator. We have 1 here plus 0.12 divided by 4 to the power of 2. So now, making use of the normal calculator, then now we say open brackets, 1 plus 0.12 divided by 4, close brackets, to the power of 2. Then we say equal. The answer that we get here is, we have 1 plus J over 2 equals 1.0609. Then we take this one over the equal sign, we're left with J over 2 is equal to, then obviously when this one goes over the equal sign, it becomes negative. We say minus 1, then minus 1, we get 0.0609. That means we have J over 2 as a small letter, J over 2. Then now what do? We do cross multiplication. Remember, this is divided by 1. So it will be the answer times by 2. Then J will be equal to 0.1218. Then we term this by 100. Then our J, which is the nominal rate compounded semi-annual, will be 12.18% per annum, compounded half yearly. Remember, half is 1/2, half yearly. Now, in other words, this means, in simple terms, this simply means that, just changing of color, I've been using too much red. This simply means, but otherwise red is a warning that you need to study the subject so that you pass it with more than 90%. So that is a warning to you. Now, in other words, it means 12.18% compounded semi-annual is equivalent to 12% per annum compounded quarterly. So these are the equivalent rate. So the 12% per annum compounded quarterly is equivalent to 12.18% per annum when it's compounded half yearly. So now this was the first way on how to convert a nominal into another nominal. Remember, nominal is an interest rate that is compounded monthly, quarterly, half yearly, or 6 monthly, or 3 monthly, or 4 monthly, or daily. So now that is the conversion that we are busy with now. And I will still use the same box in terms of the answer in response to 2.6, because 2.6 is another very lovely conversion. It's an exercise already, but I can combine them because they are both very short. Now it says exercise 2.6, conversion of nominal rate to another nominal rate equivalent. Then it says what nominal rate for quarterly compounding, meaning our required is per quarter. So now the minute we know what we are required, then it means we just say 1 plus j over 4, because this we are required to calculate the quarterly compound that is equivalent to the 12% compounded monthly. Then that is equal 1 plus, we can say that is 0.12 divided by number of months in a year, which is 12 to the power of 12. Now, and I want to highlight again, the interest rate that is given is always on the right hand side of the equal sign. Meaning, the minute you see that there is 12% that is compounded monthly, you know that the 12% must go over this side of the equal sign or of the formula. Then after you divide by the number of times this 12% is compounded, which is 12 times, then to the power of the number of times this given rate of interest is compounded, which is also 12. That is the frequency in which the interest is compounded over the period of a year. Then after now, then after we continue with our workings now. Then what do we do? Remember, rule number 1, you eliminate the power on the left hand side. By doing what? By dividing by the same power. Then you do the same on the right hand side. Then after we have divided by 4, there will be left with 3. That means our answer becomes 1 plus I over 4 equals. So now let me use my manual calculation once again. It is open brackets 1 plus 0.12, open brackets 1 plus 0.12 divide by 12. Remember, what I'm calculating is the 1 over the equal sign first. When that one is done, then I will come on the first side of the equal sign to the power of set 12 divided by 12, or 0.12 divided by 12 to the power of 3. Then now after I say to the power of 3, it gives me 1.030 1.030301. Then now we have to take this one over the equal sign on the next stage. Then we'll be left with I or J. I like to say I don't know. because there's an I formula. I over 4, which is our M, is equal to minus 1 here, which is 1, 0.030, 1.030, 31 minus 1, remove that one there, then it will give us minus 1. We will be left with 0.030, 31. Then now we have j over 4. Then we know this number is divided by 1, so j times by 1 will give us j. 4 times that, we'll have our j equals, then we times this by 4, it will give us 0.1204. Then we multiply this by 100, then our j will be equal 12.1204% per annum compounded. It is compounded quarterly. Compounded quarterly. Please don't write the way I write, but I know 1/4 is a quarterly, then I put ly. Now once again, what does this mean? It simply means that 12% per annum, that is compounded monthly, is equivalent to 12.1204% per annum compounded quarterly. Remember, we are converting nominal into nominal equivalent, so it is still nominal. Remember, nominal is compounded monthly, half yearly, 2 monthly, quarterly, or daily, or any time of compounding period, or any number of times the interest can be compounded, but we know that is nominal rate of interest. So now we have dealt again with the second example, which is under now 2.6, in terms of the calculation of the conversion of the nominal into nominal equivalent. Then now let us go again to the last one, or the last scenario on the conversion of the nominal into nominal equivalent. Then now we are told in this scenario once again that we have an interest rate that need to be converted, and it says what nominal rate for daily compounding, now it is for daily compounding, is equivalent to 18% per annum compounded semi-annually. Remember, I said to you the interest rate that is given goes on the over the side of the equal sign. That is why you substitute this one. The one that is given is the one that goes over the equal sign of the formula. What do I mean by that? I mean the 18% goes over the equal sign. This is where you substitute the 18%, meaning over the equal sign there you have your 1 plus 0.18 divided by the number of times the interest is compounded, which is the given interest compounded, which is semi-annually, then divide by 2 to the power of 2. Then after now, this one is daily. They said what nominal rate of daily compound. Let me read that one very well. What nominal rate for daily compounding is equivalent. So now meaning daily, we have 365 days in a year. That is what now we are looking for, the daily compound that is equivalent to an 18% per annum that is compounded half yearly or semi-annually. Then now let's go to our formula, as I've already highlighted that to you. We have 1 plus j over 365. Remember, we cannot substitute this j because that is what we're looking for. Then to the power of 365 is equal, open brackets, 1 plus 0.18 divided by 2. Why divide by 2? Because the given rate, the given nominal rate is compounded semi-annual or half yearly. Remember, if it was quarterly, that will be 3 times. Sorry, that will be 4. because there are 4 quarters in a year. So to the power of 2. Don't forget the principle. After you have substituted, what do? You eliminate the power on the left hand side of the equation. Now our power on the left hand side, it is 365. So we divide by 365. For every debit entry, there is a credit entry. That means whatever you do on the left hand side, you do it on the right hand side. Now, and in science they say for every action there is a reaction, but in an opposite direction. So now we have eliminated this. That means we are left with 1 here, but here it will definitely be decimals. Let me just verify. Now it will be 2 over 365. Definitely there are many decimals there. You don't have to worry about the decimals. All that you need to do, you just need to make sure that this is in brackets when you put it in your calculator, or you can still put the decimals, which is 0.0054795. That will still be 100% correct, and you say to the power 0 point something something something. Now let me then continue. Just want to rewrite this one and say we have 1 plus j over 1 j over 365 equals, then we have 1 plus 0.18 divided by 2 to the power of 0.0054795 if you choose to take that decimal and you type it as it is. Otherwise you can punch this number as it is without having to rewrite it in decimals. Therefore now on this side we'll have 1 plus j over 365. Please don't take this approach, it's kind of a very long approach, but there was no necessity for me to go that long. Open brackets. Remember, we start on the right hand side after we have eliminated that power. Remember, 365 divided by 365, it gave us 1. Any number to the power of 1 gives you the same number. That is why I seem to be ignoring the left hand side power after it has been divided by the same number. Then now we have now to say 1, open brackets, 1 plus 0.18 divide by 1 plus 0.18 divide by 2 to the power of, then we say to the power of second function dip, open brackets, 2 divide by 365. Then we go equal. Then we get an answer of 1.000472318. Then now we take this one over the equal sign. Our j over 365 is equal to 1.000472318 minus 1. Then after, when you say minus 1, it will give us the same number but without the 1. Then it becomes 0.000472318. Then we multiply this by 365. And I think now you understand why we multiply by 365, because we have j over 365. This is divided by 1. 365, we do cross multiplication like that. Therefore now we'll be left with j equals 17. Remember, after you have multiplied that, don't forget to multiply by 100. Because of space, I want to multiply on spot. Then after you are done with that, you multiply by 365, sorry, by 100. Then we have 17, 23.96092% per annum, compounded daily, meaning an interest rate of 18%. that is compounded semi-annual, meaning half a year, is equivalent to 17.2396092% per annum, that is compounded daily. So guys, with that, I hope I've made myself very clear in terms of the compounding, in terms of the conversion of the nominal into nominal equivalent. With that, guys, thank you very much. Practice other exercise that you get hold of them to master this very well. But it's an easy kind of question to me on this, to be honest. Thank you. God be with you.